All right, so let's start with the unit circle. We're going to start with what we know. So the unit circle is 1, 0, 0, 1, negative 1, 0, 0, negative 1. I also know that 0 degrees, 90 degrees, 180, 270, and a full rotation was 360. And every ordered pair goes cosine the angle, comma, sine the angle. So, as I go around the unit circle, if I want to do y equals sine x, the sine of 0 is 0, the sine of 90 is 1, the sine of 180 is 0, sine 270 is the y value, negative 1, 360 came all the way around. So what we had was y equals the sine of bx, where the amplitude is the absolute value of A, and the period length was 360 degrees divided by B. This is what you learned yesterday. And we're going to add one more thing today. If this is the full transformation, A still represents amplitude, absolute value of A. B is still going to be connected to the period length, 360 divided by B. Now, this follows quadratics, square roots, absolute values, exponentials, logarithms. What does H do? How does H switch? Left, right, and it does the opposite of what you think. And then what does the K do? Up, down, and it does what you think. So what we're going to do is I'm going to teach you like a two-step process. We can always start with y equals a sine bx. We know how to do those. And you can either use pretty colors, those of you that like your colored pencils, you can do that. Or what I'm going to do is I'm going to do dashed solid, where the solid is the final graph. So watch this. Here we go. Well, we're not going to graph these. We're just going to describe the transformation. So go ahead and jot this down. Example 1. So in this one, does anybody want to tackle letter A? Y equals sine the quantity x plus 90 degrees minus 2. How does this one shift? Katie, you want to try it?
Left 90 and down 2.
Awesome. This is left 90, and we'll say degrees, and it's down 2. Okay? So it does the opposite of the inside, same as the outside. Yeah.
So when you're graphing these, if you're doing down 2, how would that affect the amplitude?
It actually does not affect the amplitude. The up-down does not affect, like, if you think about our formal definition for amplitude is 1/2 the distance from the maximum to the minimum. it keeps that intact. But it's like I've taken the graph and I've just taken the whole thing up or down. So do you see? Like, so maybe my max and my min, instead of going 2 to -2, is 5 to 1. But half of 5 minus 1 is half of 4. So, great question. All right, how about letter B? Who wants to tackle this one? Daria?
Right 60 degrees up 1.
Good job. Right 60 degrees and up 1. All right, now we're ready to graph. Example 2, graph y equals sine x plus 1. So when we do the left, right, and up, down shift, I'm going to show you 2 steps. Step 1, and we're going to write it out formally, and then we'll do it. Step 1 is graph y equals a sine bx. Find a, or amplitude, and period. Leave a space. Step 2, shift the HK. These are going to be the general steps. Step 1, you graph y equals a sine bx. Find your amplitude and period, and you're going to graph it. After you've graphed it, and if you're wanting to go with me, I'm going to make it dashed. Step 1 is dashed. Then step 2 is take the graph and shift it the HK, and we'll make it solid. So, if I'm on step 1, I'm going to graph y equals sine x. There's no a, there's no b indicated, so they're 1s. So my amplitude is 1, and my period length is 360 over 1, which is 360. So I'm going to make 4 tick marks to the right, label it the period length. 4 to the left, and just mirror that with your negatives. And because I'm going to eventually go up 1, I made my extra tick up. We'll deal with that in step 2. So sine starts at 0, 0. It goes to the a value, which is up 1, 0, -1, 0. Make this 1 dashed. You'll see why in a moment. And then continue the pattern. Oops, I made that one up a little bit too high. Let me go back here. That only needed to go up to, there we go. Step 2, shift HK. This one is just up 1, correct? It's just up 1. So what I'm going to do is I'm going to take every point that I plotted, and I'm literally going to shift every point up 1. So I'm going to go up 1, up 1, up 1, up 1, up 1. Continue the pattern. And you can see literally from my dashed graph to my solid graph, the whole thing has just been shifted up 1 unit. So step 1, graph y equals a sine bx. Find your amplitude period, make it dashed. Determine the shift h and k, the left, right, the up, down, and then literally take the points and shift them. All right, example 3. We want to graph y equals sine the quantity x minus 45. So my amplitude is 1. The period length is 360 over 1, or 360. So I know these first two aren't very interesting because all I'm doing is the up, down, and the left, right. Alright, we know sine, 0, 0, up to 1, 0, 0, down to negative 1, and I'm going to make this one dashed. Step 2, this one's going to be right 45 degrees. Alright, well we have a problem here. What does one tick mark represent on this graph? 90 degrees. And I need to go right 45 degrees. So, related to tick marks, what is that? Half of a tick mark, okay? Do you understand that? If one tick mark's 90, and I want to go right 45, I'm going to take every point and move it half a tick. So watch this. I'm going to take 0, 0, and it's going to go here. Take this, and you're going to go half to the right, half to the right, half to the right, half to the right. Take every point, and then make this one solid. And then it's really neat when you look at it. You can see the graph. It's like you picked it up and moved it right, half of a tick mark, which on this graph is 45 degrees. So it's not always the same. It depends on what your tick marks represent. All right, everybody got it okay? All right, last one. We're going to put this one together. Or at least I think it's the, yeah, this one's the last one we're going to do together. Then I'm going to give you homework. Just practice this. And I want you to notice, I didn't change the A and the B on any of these. We're going to do that tomorrow. I thought we'll just work on the left, right, up, downs today. So we want to graph y equals sine the quantity x minus 180 minus 3. So step 1 is going to be, I want to graph y equals sine x. So I apologize, these are not very interesting. The amplitude is 1. The period length is 360. I make 4 ticks to the right, call it the period length. The amplitude is 1, but can you tell? Let's do some forward mental thinking. If I'm going to be shifting down 3, let's make 3 more ticks, because I'm going to take every tick and move them down 3. So let's just be proactive with that. So here we go. Sine x starts at 0, 0, goes to 1, 0, negative 1, 0. Follow the pattern on the left side, make it dashed. My second step is to do the shift. Anybody want to tackle the 2 shifts we're going to do?
Left 180, or right 180.
Right 180. Okay, I'm going to take every point and move it right 180 degrees down 3. But right 180 degrees isn't 180 ticks. Like, how many ticks am I going to go? All right, good. You have to figure out what the ticks represent. They are not always 90 degrees. It's if the period length is 360, a tick is 90. So I have to take every single point and move it right 2 ticks, and down 3. So I'm going to have to add 2 more ticks on the right, okay? Maybe go back and add 2 ticks on the right. So if I start at 0, 0, you go right 2, down 3. So I go to this one, right 2, down 3. Right 2, down 3. Right 2, down 3. Right 2, down 3. If you can handle the pattern from here, go for it. If not, keep following your points. So if I was at negative 180, right 2, down 3, right 2, down 3, right 2, and down 3. And let me give you the homework real quick.